um, I'll start, I guess, by drawing the reference triangles for a 45, 45, 90. Obviously, the angles are 45 and 45. That means the sides are the same. And then the legs are generally x, and the hypotenuse is x root 2. So what that means is if you're going the direction of leg to hypotenuse, and maybe this will make it easier, you multiply by the square root of 2. When you're going hypotenuse back to leg, you are dividing by the square root of 2. So in one case you're multiplying, in the other you're dividing. And then the one that you're probably more likely to see is the 30, 60, 90 triangle.
Mm-hmm.
So the 30 is across from the short side, the short leg, the long leg is across from the 60, x, 2x, x root 3. So if you're given the short leg, to get the hypotenuse, you just double or multiply by 2. To get the long leg, so going from x, you multiply by the square root of 3. But there's also the possibility that I could give you the hypotenuse. And the hypotenuse, to find the short leg, you divide by 2. So basically you're undoing this one. You divide by 2. Okay. To find the long leg, you really need to find the short leg first. So you always find the long leg through the short leg. You would then multiply by the square root of 3, that whatever number you get there. And then the most difficult case is when I give you the long leg, and you would then first find the short leg, and you do that by dividing by the square root of 3. And then from there, you can find the hypotenuse by doubling or multiplying by 2. Okay, so really, like, the first one you probably know pretty well, pretty comfortable with. The second one, you probably know how to do the short leg, the hypotenuse, and the long leg. And probably similarly, this one, it's generally the third one where, you know, there's a bit more confusion or just challenge. But this is it. Like, the nice thing is that this is everything. You know, there's no other possibilities. So let me have you try out a couple of each. So here's a 45, 45, 90. And let's say that this is 8. I'd like you to find x. And then let's try this one. Let's say it's 3 square root 2. And I want you to find the hypotenuse. We'll call it c this time. So will you give those problems a try?
Mm-hmm. Wait, so in the first one, what are we trying to find again?
You're trying to find x, and because you're given the hypotenuse, you divide by the square root of 2. You take 8 and divide it by the square root of 2. And so this right here is not the final answer. Like, you would never see that in a multiple choice. You have to rationalize from there. Do you have an answer for me on this first one?
I don't.
Okay, so to rationalize here, you multiply the top and bottom by the square root of 2. And on the bottom, that's the square root of 4. And that what's nice is that that's a known number, that's 2. On the top, you leave it as 8 root 2, 8 root 2, but now you can divide 8 and 2 and get 4 root 2. So like if we were to think about what the answer space might look like here, that's why you have to know the skill is the answer space might be like this, like 2 root square root of 2, 2 root 2, 4 and 4 root 2. So it wouldn't give you any like hope of like guessing. You would have to be like, well, how do I rationalize this thing?
Mhm.
Okay. So let's actually try another one like that before we move on to the 30, 60, 90s. So let's say I give you this 16 and I want you to find X. Last time I mentioned that one approach is to set the known side, this is the known side, equal to the reference side, this is the reference side. So you literally set 16 equal to X root 2 and you solve for X. But the thing is you always do the same action to solve for X. You always divide by the square root of 2, which is why in the previous problem we got the 16 divided or 8 divided by the square root of 2. So what is Julie, what's the next step here? What do we need to do to make this so that it's an answer that's we might see in a multiple choice?
You would. Oh, okay. So you would, I guess, multiply the. Oh my gosh, I can't like think of how to phrase it, but you,
Whatever you want to say will be fine. What are you gonna multiply the top by?
the square root of 2,
Square root of 2 and the bottom by.
and the same to the bottom. Yeah.
That's
Okay,
right.
there we
Okay.
go.
Yeah. So 16 square root of 2 over the square root of 4, which is 16 square root 2 over 2, which is 8 square root 2. So the thing to remember here about rationalizing, which is a skill that is on the exam, is you always multiply by the bottom. There's of course exceptions, but if it's a root of a number, you just multiply it by the bottom. So let's take a look at like a not like it's not really in the same class of questions, but it would say something like this: simplify 9 divided by the square root of 3. What would you multiply the top and bottom by this time to rationalize it?
The square root of 3.
The square root of 3. Okay. Now the top 9 square root of 3. What about the bottom? What does the bottom become?
The square root of 9.
Square root of 9. What is the square root of 9? It's 3. So it's 9 root 3 over 3, and you can divide these. So it becomes 3 root 3.
Okay.
Let's do a few more because I think this could be a really useful skill here. Let's say it's 60 divided by the square root of 5. Will you simplify this one for me, please?
Is it 12 root 5?
It is. Perfect. Okay, so let's increase the difficulty just slightly here. Let's say I wanted you to simplify, and again, that word actually also means rationalize. Simplify covers a lot of things. Sometimes you can even say the word like rewrite. You might see that. But let's say it's like, let's go 14 over 3 square root 7. Okay, so this time there's not just a root, there's a number there. So you actually have two paths here. One is not the right path, but sometimes students do this. You actually only want to multiply by the root. And sometimes students think to multiply by the whole thing, or they've been told to multiply by the whole thing, but you don't need to, just the root part.
Okay.
So whatever's in the root, that's what you multiply by. Okay, now in the top, 14 root 7, great. On the bottom, these two are what you multiply. The 3 just comes along. And you're probably noticing, of course, a pattern here. The square root of a times the square root of a is the square root of a squared, which becomes just a. So whatever you multiply the root by, it becomes just that number. Do you follow that? Because it's really the square root of 49, which is 7.
Mm-hmm.
And then you can take this 14 and divide it by 7. Because you can choose to sort of do it in any order. Like that 3 can be written over there, and there's the square root of 7. So now it becomes 14 divided by 7, which is 2, square root of 7 over 3. Do you see how those numbers kind of work together and move around?
Yeah.
Okay. Now, alternatively, this could be written this way: 2/3 square root of 7. That would be okay. They're equivalent.
Okay.
Let's try another one here. Let's have you try this one. 8 over 5 square root 2. Will you try simplifying that, please? How are you doing on this one?
Um, Good. So I have a question. So, um, I got 8 square root 2 over 10, but would that have to be reduced further to like 4 square root 2 over 5?
Yeah, so there's a couple of ways you could write it. One is like is to actually leave it like this, or like you did, you can put the 10 there, and then yeah, you divide both of these by 2 to get 4 root 2 over 5.
Okay.
All right, so let's try another one here. Let's go, because I really want you to get this, really well done. Let's go 20 over 3 square root 6. You try that one, please.
Okay. I got 10 square root 6 over 9.
So that's, you said 10 square root 6 over 9?
Yeah.
That sounds correct. Yeah, that is correct. Good. Okay, so here's how this, like, and unfortunately we got to increase the difficulty, and there's always this sort of like jump when you go from numbers to variables. Okay, but if we apply the same like recipe, and like, let's say it's x squared over 4 square root x, what would you multiply the top and bottom by here?
You would multiply both by the square root of x.
Yeah, I'm helping you here because I want you to see it's really no different. Okay. And maybe you're thinking, well, there's other things you do. Yeah, there are, but let's just carry this through. X squared square root of x over 4x. The x's, and there's a lot of them there, but these right here are what can simplify. X squared over x is x to the 2 minus 1, which is x.
Okay.
So maybe that wasn't a fair question. So let me try it. Let me try another one here. See if we can get you to. But let's say it's like 3 over square root 2x. Okay, what would you multiply the top and bottom by to rationalize? Sorry, this thing got wonky on me. And the answer is always whatever is under the
2x.
root. Yes, root of 2x. So it doesn't matter. It doesn't really matter what it is. You always multiply by what's under the root. So it becomes 2x in the bottom because those match there. Okay, but now nothing simplifies. Okay, so here's how you might see it though in a real practice problem. It would be like 9 over square root of 3x. Could you try simplifying that one, please?
9 square root 3x over 3x.
So that is true, but that's an intermediate answer because the 9 and the 3 can reduce. Right? They cancel. That would make 3 square root 3x over x. And this would be the answer.
Oh, okay.
Now, to be fair, on a multiple choice, this answer would not be there. They do not put like what I'll call equivalent answers, which probably really isn't the right word. They wouldn't put the non-reduced one down. So like maybe you would know, okay, 9 divided by 3 is 3. Great, I got it. All right.
Okay.
So let's try one more here. Let's see if we're moving really well through this. Let's say it's 12 over square root 2x. Go ahead and give that one a try, please.
Six square root 2x over x.
Perfect. Over just x. Yeah, that's good. Okay, great. So we did all this because we were trying to like better understand how to deal with some triangle problems, and like here is potentially a a question you might see on a standardized placement test or standardized test like we're reviewing for. So when I show you that these sides are the same, it doesn't matter that they're labeled A and B, they're really the same. But now I could tell you that C equals well, let's not make this too difficult. Let's just go with C is sorry, let me just try. I'm thinking through how we're going to do this. So do that. C is 10. Sorry, just give me a moment here. 20. Over. Yeah, let's just leave it like this. Let's just say C is 20, and they would ask you, what is the value of A? Okay. And you would say, okay, well, it's a 45, 45, 90 triangle. So the 20 equals x root 2. To solve for x, I need to divide by the square root of 2. And this is the part we've been working on for the last 10, 15 minutes here. So I think you can now do that pretty routinely. So we don't need to do this. But the moving to the more difficult triangle. Okay, they would tell you that this is 30 degrees, which means that across from it is the short leg. And they might label it a certain way, but we'll keep it simple here. But they might say, okay, 15 is the long leg. And the problem might ask you, well, what is, actually I shouldn't point there. What is the short leg? And from the reference triangle, when you're given the long leg, 15 equals x root 3. So to solve for x, you divide both sides by root 3. And this on the left, I do want you to do this one on the left here. We need to be able to rationalize that. How are you doing on this one?
I know it's the same, but I'm like a little confused.
Sure. So the the same approach, you have to multiply the top and bottom by the square root of 3. So if you haven't done that, please do that and let me know what you get on the top and the bottom.
Am I just doing it to the 15/3?
Yeah, I mean, this is the problem we're solving. Like everything else is build up around the problem, but like this is what you've got to be able to do. Like that's the skill we're trying to like get you to be really successful at. And you know, you'll notice a pattern.
I got 5√3.
Yes, because the 15 divided by 5. Yeah. So like that's what I'm trying to get you to do, Julia. And like I don't want you to overthink it. Just try to. I'm really trying to give you problems where you just repeat the same steps over and over, because we really want to get to the more complicated problems, which are, you know, using this. So again, let's say I give you a 30, 60, 90 triangle, but this time I orient it slightly differently, where here's the 30 degree, which is across from the short leg. It's the short leg. This is the long leg down here. And I tell you the long leg is 21. And the question could say, well, what is the short leg? And you're supposed to mentally, you know, have an image of this, just be like, all right, well, that's X, because that's the short leg, that's 2X, that's X√3. And you set the long leg equal to the reference side. So you set 21 equal to X√3. And I want you to solve for X. And again, it's the same thing. You divide by √3, and then you got to rationalize. So go ahead and try that. Let me know when you've got an answer there for me.
Um, 7√3.
Yes. So X is X is 7√3. And I want you to realize like what X represents in this problem. X represents the short leg. Do you see that?
Mhm.
So when you found X, even though you're doing this equation, you're really finding the short leg. And that's what I'm trying to like hopefully break through and like make that clear. Because if you know the short leg, how do you find the hypotenuse? Well, you double the short leg. So when if I really want the hypotenuse, if you want the hypotenuse, you have to double this number.
Oh, so double the short leg to find the hypotenuse?
Exactly. Yeah. And like the words are more powerful, double the short leg. So that means you multiply this by 2. So it's 2 times, actually, let me not do it this way. Let me try it differently. So the long leg is 2 times 7√3, which is 2 times 7. That's 14 square root 3. So let's try another one. Is that okay?
Yes.
Okay. So let's again say I give you a 30, 60, 90 triangle. But this time, I tell you that this is 9 over 2. And that's the long leg. The reference triangle again, and I'll keep drawing this, but this is the picture you've got to have. You got to say, okay, this is x root 3, or start with the short leg, which is x. That's 2x. That's x root 3, and you set these equal. So this time it's a little bit weird because it's got the fraction in it, right? And so you're dividing by root 3 on both sides. And the issue here is like, well, what do I do on the left? It's like, well, so let's just a little bit of reminder here. When you're dividing, it's really like multiplying by the reciprocal. And whenever you're dividing by just one thing, it actually just goes on the bottom there. So it becomes 9 over 2 square root 3.
Okay.
So now what do we multiply the top and bottom by to rationalize?
Square root of 3.
Square root of 3. And on top, it's 9 root 3. And on the bottom, it's, well, what goes on the bottom? You tell me. 2 times, or
It's 2 root 9.
which is 3. 2 times 3.
6.
Which is 6. Yeah. So it's 9 root 3 over 6. These can reduce though, right? They're both divisible by 3. So again, if we go back to our picture, what does X represent? What did we just find here in terms of like words? Like this is X root 3 is the long leg. X represents the short leg. Short leg. So we literally have the short leg. Yay, we have the short leg. How do you find the hypotenuse? What's the words?
To find the hypotenuse, you double the short leg.
Yeah, so it's 3 root 3 divided by 2. Doubling means to multiply by 2. So doubling by 2 here just means, I mean, you can multiply in by 2, but you can also see that they cancel. So it's just 3 root 3. Okay, so let me have you try one more here. If that's okay. So I'll give you a, kind of same triangle again. Here's the 30 degrees. And this one is 12 over, actually, let's not do that. Let's do 15 over 2. and I want you to find the short leg. And then I want you to find the hypotenuse. So it's really similar to the last problem there.
Okay, so the first one I did, okay, so to find for the hypotenuse, I got 5 square root 3 over 2.
I'm sorry, say that one more time.
So I finished the first one and
Yeah,
I got
short leg. I think you said
5,
5 square root 3 over 2.
yeah.
Perfect. Okay, and what would the hypotenuse be?
I just did the, wait, so I'm sorry, I'm confused. So the 5 square root 3, what part of the triangle is that? Is that the short leg?
Well, all of this is the short leg, yes. All of this.
Okay, so short.
Because it's X, so to speak. It's like it's representing the
Okay, and then
so to find the hypotenuse, you're just doubling the short leg. So you're taking this right here and you're multiplying it by 2. So if you prefer to multiply the numerator and make it 10 root 3 divided by 2, you still have to simplify by dividing.
oh, okay, so it's just 5 root 3.
Yes, yes. Now
Okay.
I've got a worksheet on 30, 60, 90 triangles and 45, 45, 90 triangles. I don't remember if I sent you the link to it or not. I'll do it again here in the email, but it really like is the only way to like get comfortable with these calculations.
Yeah.
So if you've got time, that's probably I know I sent you a lesson plan, but probably the best thing to do is to just work on those worksheets. And they sort of step through it. So like if you go back to the beginning of our lesson, there's a bunch of problems that are grouped where you just do this. You just do this over and over again.
Mhm.
And then there's another grouping of problems where you just do this over and over again. And so the way the worksheet is designed is like you should do as many of these until you're like, I got it. And then you move to the next. I call them types. So I think you can see that in the worksheet. And then similarly, you would do that down here with these. So I'll put that in the email. Probably that's the best use of your time between now and then we can get back to working on some SAT style questions
Okay.
after that. But that does take us into our lesson for today. We're scheduled to meet again on Thursday, so look forward to helping you then, and hope you're doing well, and I'll see you next time.
Okay. Thank you.
You're welcome. Bye now.
Bye.